first example is x cubed plus 4x squared plus x minus 6 is divided by x plus 1. Now, I want to show you how doing long division, I can get a remainder, so that when we do remainder theorem, you believe me. Now, you don't have to. We're only going to do long division once. After that, we're going to do synthetic division because it's just easier. But this is what we have here. So we have x, need a marker. So we have x cubed plus 4x squared plus x minus 6, and it's divided by x plus 1. So I'm going to do long division first. Everyone's paying attention? Okay. So I have x plus 1, and it's x cubed plus 4x squared plus x plus 6, or minus 6. We're going to divide that into that. Okay? So I'm just showing you this one long division question. You can do it on the very back if you want. There's a blank piece of paper because we're going to do remainder theorem for this question in that spot. So if you want to show a long division, you can on the back. But anyways, if I lose you, it's okay. We have 2. We're going to look at 2. And I'm going to say x times what gets me x cubed? X squared. So I put an x squared up here. I go x times x squared is x cubed. X squared times 1 is 1x squared. And then because it's long division, I subtract. And those cancel, and I get 3x squared. Then I add x. And I go x times what is 3x squared? 3x. 3x times x is 3x squared. 3x times 1 is 3x. And then I subtract them. Those cancel. X minus 3x is negative 2x. And subtract 6. X times negative 2 times what is negative 2x? It's negative 2. So I get negative 2x minus 2. Cancels, and I get negative 6 minus 2, and I get negative 4. So I know the remainder is negative 4. That's what I'm going to take from this. Okay? So doing long division, I can get that the remainder is negative 4. Cool. Well, on the first page, we have remainder theorem. So remainder theorem states that if I take the solution to the factor, so I'm dividing by x plus 1. If I take the solution to that, so I solve for x, and I plug it in for every x, it'll give me the remainder. That's what remainder theorem is. Okay? So long division, like I said, we're going to do this once, and then after this, we're going to do synthetic division for the rest of the day. It's easier. But this is just proving through long division because you haven't learned synthetic. All right, so we go back here, and I want you to determine the remainder. So all I want is the remainder. So I could do long division and get the remainder, or I could use remainder theorem. Remainder theorem, what we do is we solve this out. We go x plus 1 equals 0. So we get x equals negative 1. Okay? So we're literally just subtracting the 1 over. Then I'm going to label this p of x. You could label it f of x, g of x, whatever. I'm labeling it p of x because it's a polynomial. So p of x equals, the polynomial, is x cubed plus 4x squared plus x minus 6. So this is a cubic function. So what we're going to learn today is how to find the remainder using remainder theorem, but we're also going to learn how to factor anything that's greater than x squared. Because right now, I can't make you factor anything greater than x squared, which you learned in grade 10. Right? After that, you'll be able to do 3, 4, or 5. So the remainder theorem states that if I take the solution, so x equals negative 1, and I plug it in for all the x's, so I do p of negative 1, it will get me the remainder. So I'm going to get negative 1 cubed plus 4 times negative 1 squared plus negative 1 minus 6. So I get p of negative 1 equals negative 1 plus 4 minus 1 minus 6. So p of negative 1 equals negative 4. And this is the remainder, which I just proved to you by long division. We got that same answer. Correct? Same answer.
So why do we have to do long division if you can just do it that way?
If I just ask for a remainder, then you can just do this.
Oh.
I did long division to prove that using long division the remainder is -4, so that you get the same solution. So I'm proving that when I use remainder theorem, I actually do get the remainder, because it was the same number.
We actually want to do long division.
No, just synthetic.
Okay.
Yeah. Okay, you guys try too. So, this one we're going to go x minus 1 equals 0, x equals 1. And you have to say p of x equals, if you want to use that format, you have to say that it actually equals this function because it doesn't currently. And then we're going to do p of 1, which is 1 cubed plus 1 squared minus 1 plus 3. So p of 1 equals 4. And then I say remainder. If you guys actually just take the number and box this whole thing, which is what a lot of you guys will do, you guys will just box the whole thing. That's not the remainder, right? 4 is the remainder. If you just box 4, that still doesn't completely say it's the remainder. It just means you boxed something. So box it and say it's the remainder at the very least. Okay? All right. We want the remainder with 2x plus 5, so we're going to have to solve that one out, correct?
Yeah.
So we're going to get a fraction. 2x plus 5 equals 0. 2x equals -5. Divided by 2, x equals -5/2.
I get a -5/2.
So we're going to do p of x equals 2x cubed plus 3x squared minus 7x minus 3. So we're going to do p of -5/2 equals 2 times -5/2 cubed plus 3 times -5/2 squared minus 7 times -5/2 minus 3, and I believe it equals 2. So I box it and I say remainder. Okay, then we're going to flip over.
I got you.
Good. So that. A little late to the game, but you know it's still the game.
I can't get that. I can't make that too.
All right. Factor theorem. So factor theorem states that if when you plug a value in, if the remainder is 0, it is a factor. Now the reason why that would be is the remainder is just what y is when you plug it in, correct? And remember in grade 11, when you did x squared plus 3x minus 4, you would factor it, you'd get x plus 4, x minus 1. And in grade 11, we were taught to set them equal to 0 to get the x-intercepts because it's y equals, and y has to be 0 when you're finding x-intercepts. And then we would set them each equal to 0 separately. So this would be x equals -4, which is actually -4 comma 0. And then this would be x equals 1, which was actually 1 comma 0. So these are actually x-intercepts. Do you agree? And we set our factors equal to what? 0, correct?
0.
And when we plug these in, we're getting remainders of what? Numbers, correct? But if the remainder is actually 0, then we know that these are factors. So this right here is a factor. We talked about this yesterday, right? When we factored something, we got factors. So these are factors. These are solutions, this part right here. But the factor theorem is very similar to the remainder theorem, except the remainder is 0. So if the remainder comes out as 0, then whatever that you divided by x plus 2, x minus 3, 2x plus 5, those are just a factor. That would be a factor of the factors if you factor the quadratic, or you factor the cubic. Okay? That's what we're learning today. So first off, we have to figure out, they can ask us, is x plus 2, is it a factor? So what's the easiest way? Find the remainder. If the remainder is 0, it's a factor. If the remainder is 7, 9, 22, anything but 0, it's not a factor. That's it. So tell me if this is a factor or not. Go. We're going to get x equals -2. So we're going to do f of -2 because they labeled this f of x equals -2 cubed plus 5 times -2 squared plus 2 times -2 minus 8. And so we get f of -2 equals -8 plus 20 minus 4 minus 8, which is actually 0. So you have to say, since the remainder is 0, you can go like this and say remainder.
Series.
X plus 2 is a factor of f of x. All right. So we're going to flip over to the next page. Today we're going to learn how to factor something larger than x squared. If you pay attention today will be your easiest lesson of the year. If you don't pay attention today, I'll lose you in seconds. No, it's kind of how math is. Okay? But this is I would consider the easiest lesson. But some people don't like it. So, here we have x, it says factor x cubed plus 2x squared minus 5x minus 6. Okay? In grade 11, or grade 10, when we go back to grade 10, it would always be factor x squared plus 3x minus 4, or factor 2x squared plus 3x minus 5, whatever it may be. Okay? Here we're having to factor an x cubed. So we have to do something called synthetic division to knock it down to an x squared. Because if we can get it to an x squared, we know how to factor that. We got taught that in grade 10. Okay? So the way we have to factor is, first off, we're going to find possible x-intercepts. Because when we found the factor of the previous one, that the x equals, was it 1 or -1? It was -2. I wasn't even correct at all. So -2, this is actually an x-intercept. Because when I plugged -2 in, I got a 0 out, correct? So I just plugged -2 into this function. When I plug something in for x, I get an output of y. I just found a coordinate, -2, 0 on here. So we know that that's actually an x-intercept, correct? So what are we trying to do? We're trying to find the x-intercepts and work them back to factors. It's essentially what we're doing. Trying to find all the x-intercepts, okay? So here, we want to get the possible x-intercepts. So the possible x-intercepts or factors come from this back number. So these are the possible x-intercepts, which leads to our possible factors. They come from the factors of the back numbers. They're possible integral x-intercepts. So they're the factors of your back constant number. So it's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are your possible integral x-intercepts. Okay? So, I'm going to teach you how to factor. We need to get an actual x-intercept that works. So what we would have to do if I took away your calculators is we'd have to plug in 1, see if we get a remainder of 0. Plug in -1, see if we get a remainder of 0. Plug in 2, -2, until we get a remainder of 0, so that we can get an x-intercept. So instead, what we can do is we can plug it into our y equals and look for an x-intercept. Let's go. Plug it into your y equals the equation. Well, some of them are integrals. These ones all are integers, but they're not always integers.
Oh, okay. But like, you can't do, like, you could use like the function that defines the. What the holy ways? Why would you do that? You can't really do that. What's you line down a little bit?
Yeah, so it curves. It's a cubic function. It makes it sideways s.
Cubic?
So what we're going to do is we're going to pull the x-intercepts off, the integer ones. So we're going to go second graph and pull the x-intercepts off. When I want x-intercepts, what do I look for?
The 0 and the y.
0 and the y, yes. So what are our x-intercepts for this one? I'm going to put them off to the side.
2.
2, 0. What else?
-1.
Negative 1, 0. What else?
Negative 3.
And there's only going to be 3 at maximum because it's a cubic function. At max, it can have 3 x-intercepts. Okay? So those are the x-intercepts, which can lead us back to the factors. So we know that the factors are going to be, instead of x equals negative 3, what's my factor going to be? X plus 3. We'll add it back over, right? And instead of x equals negative 1, my factor is going to be?
X plus 1.
X plus 1. And instead of x equals 2, my factor is going to be? So I know those, I actually got all 3 factors off my calculator, right? So I know what they need to be in the end. I have a good understanding of what it needs to be for my answer. But if I just pulled these off and gave an answer, I get no marks because it'll say algebraically. It'll say factor algebraically. And then you just use your calculator and there's no algebra and you get no marks, right? So how can we do this algebraically? It's called synthetic division. So what we do is we can take any of the x-intercepts. We can take negative 3, we could take negative 1, we could take 2. I always take the smallest one so that we all follow the same mathematics. But you could technically take any of the 3 and do synthetic division with them, and then you'll factor out your quadratic at the end, and you'll get the other 2. So we can use any of these 3. I'm going to use the smallest one just so we're all in the same, doing the same thing. So we're going to go x equals negative 3, and then we're going to make an L, which is a synthetic division symbol. The synthetic division symbol has numbers at the top and numbers at the bottom. Numbers at the top and numbers at the bottom is what we're going to do. So we always have to make sure that in order to do this that we can rocket count. What does rocket count mean? It means rocket count the exponents. So like 3, 2, 1, blast off. Okay? So here we have 3, 2, 1, and then x to 0 technically. Blast off. So if I can rocket count, I'm golden. If I can't rocket count my exponents, I just put a 0 placeholder in for that spot. Because what we're going to do is we're going to take the coefficients of these numbers and put them on the top line of the synthetic division. So this is a 1, I'm going to put a 1 here. Then I'm going to put a 2 next to it. Then a negative 5, and then a negative 6. Okay? Now, what we're going to do is follow the same steps. We are going to multiply, add, multiply, add, multiply, add, multiply, add until we're done. Literally, that's it. Multiply, add, multiply, add, multiply, add. So, we're going to drop one number, and then we're going to multiply, add. Now, the first one that I show you, I'm going to actually draw arrows where I multiply and add just to prove points of how to do the steps. But after that, we won't do it. We'll only do this one arrow, this arrow right here. This arrow is to drop down the 1. That is the only arrow we will do after this example. I'm going to have more arrows just to prove the mathematics that we're going to do. So we drop down the 1 and then we multiply, add until we're done. Literally. I lose people after this, but that's all we're doing. Multiply, add, multiply, add. So we're going to multiply these two numbers. What's negative 3 times 1?
Negative 3.
Negative 3. So it comes up here. We're done multiplying, so what are we going to do? Add. 2 plus negative 3 is negative 1. We're done adding, so what are we going to do now? Why did it do that? We're going to multiply. Negative 3 times negative 1 is?
3.
3. So we're going to bring that up. And then we're done multiplying, so now we're going to?
Negative 2.
Add. Negative 2. We're done adding, so now we're going to multiply. Negative 3 and negative 2 is 6.
0.
Then I add them, and I get 0, and I box this because this is my remainder. And you screw that if when you're doing synthetic division, that does not come out as a 0. Because we're trying to find the factors, right? And when you find factors, the remainder is 0. We agree?
Yeah.
So one of my factors comes from up here. So this x equals negative 3. The factor was x plus 3. So that's one of my factors. I'm going to write it down here so I don't forget about it. So glad it's doing this again. You know, I was missing the blue boxes. So Super happy about that. Okay. So we're doing division. Boys. Combined you and behind you. Both shaking your bottles like no one's business. Bottle shaking in water.
So similar. Isn't that right, Alex?
All right. So we took, paying attention, we had x cubed, we took an x out. Do you see this x here? We took an x out of x cubed.
Yeah.
So we rewrite what's left over here. This is the quotient, the answer down here. We rewrite it with 1 less x. So if this is x, we divided an x out. This is now going to be 1x squared, and then you just go down by 1 each time. Minus 1x minus 2. That's these with x's. Now that, my friends, we can factor. We were taught how to factor that in grade 10, correct? So we do synthetic division to get ourselves down to an x squared, and then off to the side we do some grade 10 math. X squared minus x minus 2. So what times what equals negative 2? What plus what equals negative 1? I think Ashton has said twice, negative 2, 1. We can go right to brackets because we have a positive 1 in front. Yes?
Yeah.
You guys will learn to really appreciate polynomials that I ask you to factor with a 1 in front, because look here, what's the first step? The first step is to drop that number, correct? So whenever your polynomial leading coefficient, the number that leads it, the number in front of the largest exponent is a 1, you get to do product sum in the very end. If this is like a 2 or a 3 or a negative 1, you're going to have to do decomp. So you'll learn to appreciate polynomials with 1s as the leading coefficient. All right. So we're going to get x minus 2 and x plus 1. And those are my other two factors. X minus 2 and x plus 1. So this is the factors. They're linear factors because they would each make a line if you drew them out. Now, we obviously just send it and hope for the best. No. First off, we checked. We said the answers would be x plus 3, x plus 1, x minus 2, which it is. But we can also check this. This is the factored form, guys, of that exact same graph. So in y1, you have x cubed plus 2x squared minus 5x minus 6, correct? Put this into y2. X plus 3, x minus 2, x plus 1. Put it into your y2. And then make your line thicker if you don't have the colored graphs. If you have the colored graphs, you're golden. If you don't, this is going to go into your y2. And you're going to go over to that slanted line beside your y2, right? And hit enter to make it thicker. And then you know you're right if it draws your original graph and then it draws your new factored form graph right on top of each other. Because that's just the factored form of the exact same equation above.
Yeah. Yeah.
I taught you that.
That's so weird. Oh,
I taught you that like 3 weeks ago.
I don't recall.
All right. Does everyone see that it matches?
Yeah.
Same graph, drew the graph on top of each other, right? So you should never walk away from a factored form being like, hope it's right. Type one in, type the other one in, and it should be the same. Oh, wait, next page. I don't even know. I don't want to know. This. We're going to factor this. It's a cubic. So at maximum, there's going to be 3 different factors. Okay? It's a cubic, so at maximum, we're going to have 3 different factors. These are the possible x-intercepts. Which indirectly is a possible factor. The factors of 15, so plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So those numbers, you would plug into your remainder theorem and see which one gets you a remainder of 0. Correct? If I pulled away your calculators. But since I don't take away your calculators, what could you do? Type that equation into your y equals now and get me the x-intercepts. correct? So make sure you're doing that. What were the x-intercepts? What and what? What are they?
-1.
-1, 0. Yeah.
-3.
Yeah.
-5.
So I'm going to pick the smallest one. I'm going to use -5, but could we use any of the other two?
Yeah.
Yes.
Easier?
Um, it possibly could be. I'm just going to use -5 because then we all do the same math. So when I get you to practice the next ones, we'll all be doing the same thing. But you could do any of the other two. Whichever one you do, your trinomial factor will get the other two. So if I picked -3, then my trinomial factor will get me x plus 1, x plus 5. If I pick -5, it'll get me x plus 3, x plus 1. If I pick -1, x plus 3, x, you know what I mean? That'll get me the other one. Yeah. Sorry, what?
Why are the possible x-intercepts in squiggly brackets?
I just put them in squiggly brackets because it just means the set of numbers. But if you just listed them without a squiggly, you'd be fine. Yeah. All right. So I'm going to choose x equals -5, which means the factor is x plus 5. And then I put x plus 5 down here because most often people will forget that one. They'll write it beside the synthetic division and never write it down in the answer to box it. You know what I'm saying?
Yep.
All right, what do we have to remember to check for? Can we what first before we start putting down any numbers? Rocket count, our exponents. 3, 2, 1, blast off. We can. So we're going to go 1, 9, 23, 15. I drop down the 1. Now I'm not going to do the actual multiplication add symbols. I'm just going to do them. So -5 plus 1, or sorry, -5 times 1 is -5. Then I add them. 9 plus -5 is 4. Then I multiply. -5 times 4 is -20. Bring it up here, then I add. 23 minus 20 is 3. Then I multiply. -5 times 3 is -15. Then I add -0. Now because it was cubed, we're going to move 1 down. So instead of it being cubed, this is going to be 1x squared plus 4x plus 3. And then off to the side, I'm going to factor that like we did in grade 10. So if you can't factor, this unit's going to suck. Oh, I hate it. Okay. Keep going. Factor that one out. Okay, what multiplies to give me 3 and adds to give me 4? 3 and 1. And I can go right to brackets because there's a positive 1 in front. So I get x plus 3, x plus 1. And then often people will box that. Remember, you need the x plus 5 as well. Because if I just put x plus 3 and x plus 1 into my calculator, I'm going to get a quadratic. And I needed to match this one. Now, do we just send it and hope for the best? No, we put this into y2. You have that one in y1 already. Put this one in y2 and see if the graph draws on top of the other graph, right? And that's why I said I make that, if you don't have the colored calculators, I make that slanted line beside the y2. There's a y2 and then there's a slant. I just hit it once, and then it makes it thicker. And then you'll see a thin one drawn and then a thicker one drawn over top of it. If you don't use the thicker part, it'll draw one and then they'll draw the other and you won't know if it's actually drawing it on top or if it's drawing it somewhere off the screen somewhere in negative land or positive land. That's not on your screen. Okay, so that's why I always make it thicker so I physically see the thin one draw and then the thick one on top. Okay, and it says factors, so these are the factors. Okay, do you see B and C? Go. So this one only has one x-intercept that you can see, correct? Now if you press y equals, if you press the graph, you'll see that there's actually 3 x-intercepts. So there would be 3 solutions, 2 of them are decimals. Okay? This isn't asking us to solve though, I'm asking you to factor. You're paying attention? I'm asking you to factor. So x equals 5, was it the only x-intercept? Yeah. I believe. And then we go 3, 1, blast off. So we're missing the 2. So we're going to go 1, 0, negative 27, 10. We have to put a 0 as a placeholder if we're missing something. Good job. Just put it somewhere that's not going to be in your hand. All right. So we're going to drop the 1, and then we're going to multiply. Multiply. Oh, we have x minus 5, and I don't want to forget that one. Sorry. So I'm going to put the x minus 5 factor down here. Did you know that if you put y equals x plus 5, x minus 5 into your calculator, that would be linear? This is actually called a linear factor. Fun fact. So everything we've found so far has been linear factors. Because if I actually graph them, they make a line, right? They're linear. X to the 1, degree 1. Okay, let's keep going. 5 times 1 is 5. Add it, we get 5. And I need to multiply. 5 times 5 is 25. Add it, negative 2. 5 times negative 2 is negative 10. Add it is 0. And then I have to take 1 off. So this is x cubed, this is x squared. So I get 1x squared plus 5x minus 2. And that can't be factored. What multiplies to give me negative 2 and adds to give me 5? Nothing in the world. Okay? If I asked you to solve means give me the x-intercepts, you would actually put that in the quadratic formula. Okay? But am I asking you to solve? No. So if I ask you to factor, best question in the world, because you're done. If I ask you to solve, worst question in the world, you have to use quadratic formula. Unless you really love quadratic formula, then best question in the world. See how we loop back, you know? So this doesn't say solve, though. It says factor. So I'm going to get x minus 5, and beside it, I'm going to get x squared plus 5x minus 2. And that's as good as it gets. So if I type this in times this, I would actually get that back. Right? This can't be factored. There's nothing that multiplies to be negative 2 and adds to 5. So you leave it like that if it says factor. This is a linear factor. What do you think this one is? You did these last year. Starts with a Q. Quadratic factor, not question mark. So then this would be the answer. But if they ask me for the they might, guys, when they ask me to factor this, they might ask me for the linear factor. They also might ask me for the quadratic factor, and you need to know what the heck that even means. Yeah. Yes. Okay, CD, go. This one, the possible x-intercepts are the factors of 6. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All right. So this one's going to end up in decomp. I know it's going to end up in decomp because the leading coefficient is a 2 and not a 1. All right. So what x-intercepts does this one have? X equals what? Negative 2?
Negative 2 is the smallest.
Okay. I'm going to prove to you that if you didn't do negative 2, you'll still get the same answer. What's another one? 3. Okay, so you can do negative 2. Don't go changing your stuff. I'm just proving to you that we get the same answer. Okay? So if I use 3, I still have rocket count, 3, 2, 1, 0. I have a 2, I have a negative 1, I have a negative 13, I have a negative 6. I drop the 2. 3 times 2 is 6. Add it, 5. 3 times 5 is 15. Add it, 2. 3 times 2 is 6. Add it is 0, which is what we need. And then this would be 2x squared plus 5x plus 2. Go for it. And my factor is x minus 3. Now I have to do decomposition to this 2x squared plus 5x plus 2. So I have 2x squared plus 5x plus 2. And I say to myself in grade 10, what times what equals 4? And what plus what equals 5? And I would get 4 and 1. And then I still get people on the test going x plus 4, x plus 1, which is not true. You need to do decomposition. So you need to replace this 5x. So we get 2x squared plus 4x plus 1x plus 2. Take out a 2x, and I'm left with x plus 2. Take out a plus 1, and I'm left with x plus 2. And then 2x plus 1, x plus 2. And those are my other two factors. Had I used negative 2, my two factors that would have came out of the quadratic were x minus 3 and 2x plus 1. Right? It wouldn't, you still get the same answer. So these are the factors. Okay, we're going to flip over to E. We'll come back to D after. What does E have? X to the 4. Now remember this, every time I did synthetic division, it's knocked an x off, correct?
Yeah.
So when I did x cubed, I did synthetic division once, it knocked an x off, I got to x squared, go to grade 10, keep on going, right? So if I have an x4, I'm going to have to do synthetic division once to knock it down to an x cubed. Then I'm going to do exactly what I just did. I'll put that x cubed into my y equals and solve an x cubed like these were, right? Do synthetic division again, knock it down to an x squared, and then do grade 10. So it's the same thing over and over. So let's look at this one. This one has possible x-intercepts are the factors of 18 this time. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. And we'd have to try them with remainder theorem, plugging them in until we get a remainder of 0, correct? We didn't have our calculators. But everyone's going to type this into their calculator, into your x4, into your y1. Type it in, and get me the smallest x-intercept. You can get me any of them. Actually, get me whatever one you want. I just want an x-intercept. From x4 minus 3x cubed minus 7x squared plus 15x plus 18. One of the x-intercepts.
-2.
Which one?
-2, -1.
Okay, we'll use -1.
-27.
So x equals -1, which means my factor would be x plus 1. I'm going to write that down here. I'm going to do synthetic division. Before I go put in numbers, what am I going to check for? Can I rocket count my exponents? So 4, 3, 2, 1, blast off. So I can. So I'm going to put my coefficients in. I'm happy. My coefficient is a 1. The leading coefficient is a 1, which means I'm going to get to do product sum in the very end and not decomp. Yay! I like decomp, but people don't. Yeah.
Can you just show us again how to get the x-intercepts on the buttons?
Second graph.
And then you have
And then you're just looking for what y equals 0. Because x-intercepts y equals 0, right? Check your y equals. You probably typed it in wrong.
Is there another way to do?
Well, that's your quickest way to find integral ones. It's like integers. If not, you'd have to go like second trace value number 2 and then left bound, right bound and find it that way. And then that can get you decimals as well. Okay. So 1 fits -3, -7, 15, and 18. And then we do the same steps. Drop the 1, multiply, add, multiply, add, multiply, add. So we're at -1 times 1 is -1. Add it. -3 plus -1 is -4. Multiply. -1 and -4 is 4. Add it. -7 plus 4 is -3. Multiply. -1 and -3 is 3. Add it. 15 plus 3 is 18. Multiply. -1 and 18 is -18. And then you get 0. If you can't see, you can move. There's plenty of chairs in different spots. Or you can totally move your desk with yourself in it, if you so choose, because I'm not picking where you're sitting. So if this is x to the 4, what would it now knock itself down to? X cubed. I'm not joking. If you can't see, literally, you just totally can move yourself. You can't see. I know I'm not see-through. so I do block the board. So if this one is x4, this is going to be what? 1 less. What's x4? This is going to start at x3 because I took an x out. Do you see this x here? This one here? I took that x out. So this x4 is going to become 1x cubed minus 4x squared minus 3x plus 18. And this shouldn't be overwhelming, guys, because this is what we just did. How do we factor an x cubed? What's the first thing we did? Put it into our calculator and looked for a x-intercept. Yep. So everyone should be typing it into their y equals. I'm looking for an x-intercept. What did you get for an x-intercept? Did anyone get one? -2. So that's a factor of x plus 2, and that's going to go here. Right? So we take that factor and we put it down at the bottom so we don't miss it. And then we're going to do synthetic division again. With 1, -4, -3, 18. Drop the 1. -2 times 1 is -2. Add it. -4, -2 is -6. Multiply -2 and -6 is 12. Add it. -3 plus 12 is 9. -2 times -9 is 18. And I get 0 again. If I don't get 0, something is wrong. Now that was a cubed, and I pulled an x out. So now what's this going to be? Squared. So I have x squared minus 6x plus 9. So once again, grade 10. X squared minus 6x plus 9. What multiplies to give me 9 and adds to give me -6. -3, -3. So I would get x minus 3 and x minus 3. How else can I write that instead of writing 2 of them? X minus 3 squared. So I could write that here. And then do I send it and hope for the best? No. This should be the same as the x4. So some people put their x3s in there right now. And then they put that in, they're like, they don't match. Yeah, because you put the x3 in. You'd have to go back, put in your x4 into y1. Put this into y2. Call it it. So this is factors. Factors. All right. Your homework is F. Go.